The art of asking the right questions. Most people think intelligence is about having answers. They're wrong. The most powerful intellectual tool ever discovered isn't a formula, isn't a theorem, isn't even a theory. It's a question. The right question, asked at the right moment, can collapse centuries of confusion in an instant. It can expose a fraud, unlock a mystery, or send human understanding leaping forward by decades. And a man who understood this better than almost anyone else in the 20th century wasn't a philosopher or a therapist or a debate champion. He was a physicist from Queens, New York, who never stopped acting like a curious 6-year-old. His name was Richard Feynman, and he had a superpower. Why most people never learn to ask good questions. Here's something nobody tells you in school. You spend 12, 16, sometimes 20 years in formal education. You learn to answer questions. You learn to fill in blanks, solve for X, write the 5-paragraph essay, regurgitate the date of the battle. But in all those years, in all those classrooms, you almost certainly never had a single lesson on how to ask a question. Think about that for a moment. Asking questions is the engine of all learning. Every discovery in science, every breakthrough in philosophy, every meaningful conversation you've ever had depended on someone asking the right question. And yet we treat it as though it's something people just know how to do naturally. They don't. Most people ask questions that are either too vague to be useful, too narrow to be interesting, or so loaded with assumptions that the answer is basically baked in before anyone opens their mouth. Most people, when they don't understand something, either stay silent or ask a question so timid it barely scratches the surface. And most people, when they think they understand something, never think to question whether that understanding is actually solid. Feynman was different. From the very beginning, he was different. The education that started in the woods, Richard Feynman's father, Melville, was not a scientist. He was a uniformed salesman. But he was, by all accounts, one of the most naturally curious and intellectually honest people his son would ever meet. And from the time Richard could walk, Melville took him out into the woods near their home in Far Rockaway and taught him something no classroom ever quite manages to teach. He taught him how to look. Young Richard would point at a bird and ask what it was called, and Melville would tell him the name, sparrow, finch, whatever it happened to be. And then, crucially, Melville would say something like, "That's what people call it." But knowing the name doesn't tell you anything about the bird. Then they would watch the bird. They would notice how it moved. They would ask why it cocked its head that way. They would wonder what it was listening for. They would follow the question wherever it led, and they would do it with full attention and genuine curiosity, not to reach a destination, but because the wondering itself was the point. Feynman later said this was one of the most important things he ever learned. Not any specific fact about birds. The lesson was about the difference between knowing the name of something and knowing something. And that difference, it turns out, is almost everything. This is the first question in the Feynman toolkit, and it's devastatingly simple. What do you actually mean by that? Not what do you call it. What do you mean? The clarification question that exposes everything. Feynman had a habit that made some people uncomfortable and delighted others. Whenever someone used a term, in a lecture, a conversation, a paper, he would stop them and ask with complete sincerity, "What do you mean by that exactly?" Not to embarrass anyone, not to show off. He genuinely wanted to know, because he had learned over a lifetime of intellectual work that an enormous fraction of what passes for understanding is actually just naming things, applying labels, using words that everyone nods along to because they sound familiar, even when nobody could say, under pressure, what the words actually mean. Try it sometime. Pick any word that comes up constantly in sophisticated conversation. Consciousness, value, energy, information, democracy. Now ask someone to define it without using circular language or synonyms. Just explain simply what the word actually points to. You'll be amazed how quickly the conversation gets interesting. Feynman used this move constantly in physics. He was deeply suspicious of mathematics that couldn't be translated back into physical intuition. If you could write down an equation but couldn't explain, in plain language, what was actually happening physically, Feynman would press you. Yes, but what does that mean? Not the symbols, the reality behind the symbols. This is not a small distinction. In physics and in life, An enormous amount of confusion is generated not by complicated ideas, but by fuzzy words that carry the illusion of meaning without the substance. The clarification question cuts through that fuzz like a knife. Here's a thought experiment. Imagine you're in a meeting and someone says, "We need to optimize our strategic alignment." Now imagine that instead of nodding, you say quietly, "What do you mean by that, exactly?" And then you wait. Watch what happens. Either the person gives you a precise, useful answer, in which case you've both moved forward, or they struggle, repeat themselves, use more vague words to explain the vague words, and reveal that the sentence was, in fact, empty. Neither outcome is bad. One advances understanding. The other reveals a confusion that would have gone unaddressed for months. Feynman's question is a kindness dressed up as a challenge, the why ladder. Now here's where it gets interesting. Clarifying what someone means is the first move. But Feynman had a second move, equally powerful, and it goes by the simplest possible name, why. But not just once. The real technique is to keep asking why until you hit the bottom, until you reach the place where you can't go any further, where you're standing on the bedrock of actual fundamental principle, and you know you're there because there's nothing underneath it. Let's try it with something familiar. Why does a ball fall when you drop it? Most people would say gravity, fine. Why does gravity pull things together? Because mass curves space-time. A relativistic answer would say. Massive objects distort the fabric of space and time around them, and other objects follow the curves. Fine. But why does mass curve space-time? And here's something interesting happens. The honest answer is, we don't fully know. General relativity describes it with extraordinary precision. It gives us the equations. But the why, the deep why, the reason mass and space-time have this relationship at all, that's still an open question. And here's the remarkable thing. Most people who confidently say gravity, when you ask why a ball falls, have no idea this abyss exists beneath the word. They think they've explained something when they've really just named something. The why ladder reveals the difference. Feynman did this in his famous interview series, The Pleasure of Finding Things Out. He was asked why magnets repel each other when you put like poles together, and instead of just giving the standard physics answer, he went down the ladder. He showed how every answer generates a new why. Why does charge generate a field? Why does the field exert a force? Why does energy want to be minimized? At every level, the questioner wants a familiar analogy to anchor the answer, and at every level, Feynman shows that eventually you run out of familiar analogies. Eventually you're at the bottom, in the place where physics simply is, without further explanation beneath it. He found that beautiful, not frustrating. Beautiful, because it means there's always more to understand. The bottom of the ladder is not a dead end, it's a frontier. This is how you can use the why ladder in your own life. When you're learning something new, don't stop at the first satisfying sounding answer. Ask why again and again. If you're learning about compound interest, ask why it grows exponentially, then why that mathematical pattern appears in finance, then why exponential functions show up everywhere in nature, and follow it until you either hit something fundamental or until someone admits they don't know. Both are victories. When you're evaluating a claim someone makes, ask why they believe it. Then ask why the evidence they cite is reliable. Then ask why the framework they're using is the right one. You will very quickly find out whether there's solid ground under their position, or whether it's opinion, stacked on assumptions, stacked on habit. Questions that test for understanding. Feynman was, among other things, a teacher, and he thought deeply about what it meant to actually understand something, as opposed to merely being able to repeat it. He developed what people now call the Feynman technique, though he never named it that himself. The idea is simple and merciless. If you truly understand something, you can explain it to someone who has no background in it at all, not a fellow expert, a curious layperson, a child. And the questions you ask when you're trying to find out whether someone understands something, rather than just knows about it, are very specific. One powerful version. Can you give me an example? Abstract understanding without concrete examples is almost always shaky. When Feynman taught, he insisted on examples, not because examples replace understanding, but because the ability to generate a good example is evidence of understanding. If you truly grasp a principle, you can find it in the wild. You can point to it in the real world and say, there, that's the thing I'm talking about. Ask someone who claims to understand confirmation bias to give you 3 examples from their own life. Ask someone who claims to understand game theory to explain the prisoner's dilemma using people they know. Ask someone who claims to understand inflation to explain it using a specific example from recent memory. The request for an example is a gentle, non-confrontational probe that reveals a great deal. Another powerful version: how would we know if we were wrong about this? This is Feynman at his most rigorous. It's the question that separates scientific thinking from ideological thinking. A real scientific claim has to be falsifiable. There has to be something, some observation, some result, some evidence that would, if found, overturn it. If someone holds a belief and can't tell you what would change their mind, they're not holding a reasoned position. They're holding a faith. This question is especially useful when evaluating expert claims. An expert who truly understands their field will be able to tell you exactly what would disprove what they're saying. They'll know the limits of the evidence. They'll know where the uncertainty lives. They'll say things like, "We'd expect to see X if this were true, and we haven't ruled that out yet." An expert who can't tell you how they might be wrong is either overconfident or not really an expert in the way they're presenting themselves. Stop. Think about that for a moment. The question, how would we know if this were wrong, might be one of the most clarifying questions you can bring to any conversation about knowledge or evidence. It's not cynical. It's not hostile. It's the most honest thing you can ask. The thought experiment is question. Feynman loved thought experiments. But a thought experiment is actually a question in disguise. It's a question of the form, what would happen if? What would happen if you were falling in an elevator and the cable snapped? Einstein asked that. The answer helped him build general relativity. What would happen if you could ride alongside a beam of light? Einstein asked that too when he was 16. The answer eventually became special relativity. What would happen if nature kept track of every possible path a particle could take, and the actual path was the result of all of them somehow averaging out? Feynman asked that. The answer became the path integral formulation of quantum mechanics. The what would happen if question is powerful, because it forces you to push a system beyond its normal operating range and look at what principles hold up and what ones break down. It's a stress test for understanding. You can use this in your everyday thinking. What would happen if this trend continued for 30 years? What would happen if the thing I'm assuming were actually false? What would happen if I tried to do this in the simplest possible way, with the fewest possible assumptions? What would happen if the expert I'm listening to turned out to be wrong? These are not idle speculations. They are precision instruments. They reveal assumptions, expose fragilities, and open up possibilities that ordinary thinking keeps hidden. The question that creates connection. But Feynman's questioning wasn't only about rigor. It wasn't only about exposing confusion or probing for understanding. It was also, and this is easy to miss, about genuine curiosity as a form of respect. When Feynman asked someone, "What do you mean by that?" he wasn't performing skepticism. He actually wanted to know. He was genuinely interested in what was going on inside the other person's mind. He was treating the other person's thinking as worth understanding. This matters enormously in conversation. Most people, most of the time, listen just enough to know when to start talking again. They're not really trying to understand the other person's model of the world. They're assembling their own response. Feynman's questioning was the opposite of this. He would ask follow-up questions not because he had a debating point to score, but because the answer genuinely interested him. He would change his mind, visibly and without embarrassment, when a conversation gave him new information. He would say, "I never thought of it that way," and mean it. This kind of questioning, curious questioning, creates a different quality of conversation. When people feel that your questions come from genuine interest rather than from strategy, they open up. They tell you things they wouldn't otherwise say. They think harder. They go deeper. The question becomes an invitation rather than a challenge. Here's a practical technique. The next time you're in a conversation and someone says something you find interesting, don't immediately respond with your own perspective. Instead, ask a question that goes deeper into theirs. What led you to think that? Or what would change your mind about that? Or even just, can you say more about that? You'll be surprised how much richer the conversation becomes. The art of not knowing one more piece of the Feynman questioning toolkit, and this might be the most important one. Feynman was famously comfortable saying, "I don't know," not as a cop-out, not as false modesty, as an accurate description of his epistemic state and as the starting point for genuine inquiry. He said once that the first step to knowing something is knowing that you don't know it. This sounds obvious, but it isn't. Because the biggest obstacle to asking good questions isn't ignorance, it's the illusion of knowledge. It's the comfortable feeling that you already understand something well enough that no further questioning is required. This is what philosophers call the Dunning-Kruger territory, and Feynman was acutely aware of it. He knew that a confident-sounding answer could be the most dangerous thing in the world if it made people stop asking questions. So he cultivated, deliberately, a habit of noticing when he was in the illusion of understanding zone. He would take a claim he thought he knew and try to actually reconstruct it from first principles, not remember it, build it. And if he couldn't build it, he knew there was a gap, and the gap meant there was a question to ask. Try this with something you're sure you understand. Really sure. Take the thing you would confidently explain to someone else and try to derive it from scratch without looking anything up. Where do you get stuck? That's where the question lives. That's where your next real learning will happen. Feynman called this kind of intellectual honesty the first principle of science. You must not fool yourself, and you are the easiest person to fool. The question is the tool that keeps you honest. A toolkit for any domain. Let's bring this together. Because the beautiful thing about Feynman's questioning approach is that it doesn't belong to physics. It belongs to thinking. It works in any domain where understanding matters. When someone makes a claim, ask, "What do you mean exactly? What specific thing are you pointing to?" When you receive an explanation, ask, "Why?" Then ask why again. See how far down the ladder you can go before you hit genuine bedrock or genuine uncertainty. When you're learning something, ask, "Can I explain this to someone with no background in it? Can I give a concrete example? Can I derive it from scratch?" When you're evaluating expertise, ask, "How would we know if this were wrong? What would change your mind?" When you're exploring a new idea, ask, "What would happen if?" Push the idea to its edges. See what holds and what breaks. When you're in a conversation, ask, "What led you to think that?" Go deeper into the other person's reasoning before you respond with your own. And regularly, in your own thinking, ask, "Do I actually know this, or do I just know the name of it? Could I build this from scratch, or am I carrying a borrowed belief I've never really examined?" These questions are not complicated. They're not sophisticated in the way that technical jargon is sophisticated, but they are powerful. Used consistently, they will change how you think, how you learn, and how you understand other people. They will make you better at almost everything that matters. The wonder at the bottom. There's something Feynman said near the end of his life that captures all of this better than any technique or toolkit can. He said that he could live with doubt and uncertainty and not knowing. He thought it was much more interesting to live not knowing than to have answers that might be wrong. He didn't have to have an answer. He felt it was fine to not know, to grope, and he found that if you were honest about not knowing, the questions became much more interesting. That's the real heart of it. The questions aren't just tools. They're not just strategies for detecting confusion or probing for understanding, though they are those things. At their deepest level, they are an expression of a particular attitude toward the world. The attitude that the world is genuinely interesting, that there is always more going on than you currently see, that the person in front of you has a model of reality worth understanding, that even the things you're most sure of deserve, occasionally, to be questioned. Feynman grew up asking his father endless questions about birds and insects and stars and forces. His father never made him feel that the questions were annoying or naive or beneath consideration. He treated every question as the serious thing it was, a mind reaching out toward reality, trying to close the gap between what it knows and what is. That reaching is what learning is. That closing of gaps is what understanding is. And the question is the reach itself. So the next time you're in a conversation and you feel that slight discomfort, that sense that something isn't quite adding up, that there's a word being used that you're not sure anyone actually understands, that an explanation has been accepted a little too smoothly, ask, not aggressively, not to score a point. Ask because you want to know. Ask because the answer matters. Ask because the question is the most honest thing you have. Ask the way a physicist from Queens, New York, with laughing eyes and infinite patience, spent his entire life asking, and see where it takes you. Because if there's one thing Feynman proved in his life and his work and his teaching, it's that the question, asked with genuine curiosity and intellectual honesty, takes you somewhere extraordinary every single time.